Hey guys, welcome back to AlgoYogi. We are doing graph series. Our next problem in the list is max area of island. Let's go to LeetCode, give this problem a read. You are given an m into n binary matrix called grid. An island is a group of ones representing land connected four directionally, basically horizontal and vertical. So left, right, top, bottom. You may assume all four edges of the grid are surrounded by water. So basically whatever grid you have been given with, it has been placed in water. So there are water on the outer bounds of all this grid. Now the area of an island is the number of cells with a value 1 in the island. So return the maximum area of an island in grid. So I think a super straightforward problem. So if there is no island, then we return 0. So this is the grid that we have. So how are we going to basically find our answer? Now you can see we have already been told that this out of the bounds, this is all water. This is all water. Okay, I'm not gonna just draw and make it dirty, but just remember this grid is inside the water. So I'm gonna move this right in the middle. Now this grid, basically there are n rows, there are n columns and m rows. Okay, how many island do you see here? How many island do you see here? I see there is one over here, there is another one over here, another one over here. So one, this one, then there is this one, then there is this one, then there is this one, and there is one more. Okay, so what are the areas of these islands? Well, the area of this island is just 1. That's the number of cells that island contains. This one has basically 4. So this is 4, this is 1, this is also 4, this is 5, this is 6, and this is 5 again. So what is the max island, max area island, we can call it area island? That is 6. That's what we written. That's our answer. So how are we going to find our max? How are we going to find the area of any island that we find out? Super simple. We have already done a problem where we find basically the number of islands. Now we are at the time we are visiting an island in this problem, we are also going to collect 1 from there, 1 as like the area of that particular cell we are visiting. So let's say I will have like a variable called max area island. Initially that's going to have basically the value 0, but then we're gonna start visiting our grid. So this is a 0, we ignore these, this is where we come across. So we're gonna call the DFS function. I'm sure you remember this DFS function from the previous problem, which is number of islands. Here in this in the DFS, we will be just making this minor change that if we are if we're calling out of bound or like some zeros, then we return 0, otherwise we return 1. That means we see a 1. So that means we will be adding 1 to my answer. So earlier I was visiting these cells and putting them into my visit set. This time I will be adding 1 to my answer when I'm returning it. So basically what I'll be doing is if I simply write this DFS function, so it's going to be simple, straightforward, and honestly, like I feel like we can just immediately write this solution. It's not super complicated, but at the same time, like let's just write our simple DFS function. So I'm going to have 2 for loops. So for I in range m, then for j in range n, then I'm going to have also a visit set that will store the visited set. Now if this grid at I and j equals to 1, that means I'm seeing a piece of land. So what I want to do is I also want to check this is not in visit, so this I and j not in visit. If this is this case, then I'm gonna call DFS and I'm gonna basically max area island is going to be maximum of this value itself, or what my DFS returns. DFS returns with I and j. That is it. This will be basically the for loop to visit my grid, and then whenever you come across one and that is not in visit set, then call DFS and then update your maximum if DFS returns a greater value. That is it. How about my DFS function? What is my DFS function is going to be? So this time DFS function is gonna be basically taking this row and column. If row is less than 0 or column is less than 0 or row is greater than equals to, I can call it R, the number of rows, and then or column is greater than total columns, so C, and then call it or grid value at R and C is equals to 0, or this R and C in visit, okay, in visited set. So if this is the case, then I'm going to return 0, because then I'm not covering any area, so I don't have to add it to my this island area. So I'm going to return 0. Else I will add this R and C to, like, add to visit, add this to visit, then return. See now, because if none of this has happened, that means none of this has happened, all these scenarios that we were covering, that means now I'm seeing a 1 at this particular cell that I'm currently visiting using my DFS. That means I want to add 1 to my answer, 1 plus, what else I want to return? DFS on all the neighboring cells. So top, bottom, left, right, because that's how horizontally, vertically, that's how you want to explore. So this is gonna be R plus 1 and C, then plus DFS R minus 1 and C plus DFS R gonna be same. Now change the column, C plus 1 plus DFS are gonna be same, C minus 1. So that is it guys. Like, this is our answer. This thing right here, this is the answer, and then I'll be finally returning the maximum area island, and that will get updated as these values are explored. So what these two functions are really doing is these are not functions, this is calling the function. So this will basically, whenever it visits this one, then it's gonna check its surrounding cells, because they all will be returning 0 to it, but this was 1, so it will return 1. So we will get the value 1 here, this will get the value 4 here, this will get the 5, 4, 5 and 6, and then maximum value will be updated with 6, and answer would be 6. Let's write our solution. Super simple, super straightforward. Okay. Oh, awesome. Okay, so let's find out our basically rows and columns. Rows gonna be length of this grid, columns gonna be length of this grid. Let's take the first row, that's the number of columns. Then we're gonna have a visit set. Visit set is going to be just a simple set, empty in the beginning, Then we're going to have, let's call it max area island, initially gonna be 0. Then we're gonna have our two for loops for I in range rows, then for j in range columns, if this grid at I and j is equals to 1, you are seeing a land, and this time these values are given, they're not given as a string just like in the number of islands, but this time they are numbers, 0 and 1s. These are binary numbers, and this I and j is not already visited, not already counted in any other island, because one piece of land could be part of one island itself, right? It cannot be part of other islands. If it is part of two islands, that means this is whole just one island, it's not two islands. Okay, so not in our visit. Okay, if this is the case, then I'm going to call the I'm going to update this max area with what? Itself, maximum of itself, or a main DFS function. We haven't written DFS, we will write it as ij, and then finally we can just return this answer. Let's write our DFS function. So definition of not this, DFS is gonna take row and column. So as we wrote those conditions, if row is less than 0 or column is less than 0, or row is greater than equals to basically rows, number of rows, or column is greater than equals to calls. Equal is because you don't want to be, because it's 0 indexed, right? Or this is in visit set, so R and C in visit, or one more thing, it is equal to 0. So grid value at R and C is equals to 0. If this is the case, return 0, returning 0. Otherwise, just add this row and column, because now it's 1, so we're going to add it to visit. So I don't know why I started writing this. So visit dot add, and we add this as like a tuple. Okay, you can add it like an array, or like combine them together, whatever you guys want to add it as, but this is also okay. So now we return 1 plus, because you're seeing a 1, so that means one cell is a 1, that is a land. Add that area to your return value, and at the same time try to ask these neighbors. What are these neighbors? Neighboring cells, row plus 1, the bottom, plus row minus 1 on the top, minus 1, and column plus 1 to right, and column minus 1 to the left. Okay, that is it, guys. That is it. Now I'm going to zoom out and run this on our test cases. Awesome, this passes. Let's submit our answer. Everything all right. Let's write down the time complexity. Time complexity is going to be big of n cross or m cross n, and space complexity is also going to be same, because I'm using this visit set to store the visited islands. So it's going to be space complexity. It's going to be, I mean, worst case it's going to be m into n. Best case is going to be 0, because if there are no island, then you don't store anything. But that's not how we calculate space complexity. It's like the worst. You try to go with the worst. Okay. Okay. Mark this problem solved. See you guys later in the next problem. I'm done. Bye bye.